Okay, so you're supposed to find the first 5 terms. So A1 is 3. The next one, there's a common difference of 10. So 10 more than 3 would be 13. 10 more than 13 would be 23. 10 more than 23 would be 33. 10 more than 33 would be 43. Now, if I put that in terms of words, excuse me, um, A2 is equal to A1 plus 10 more. And A3 is equal to A2 plus 10. A4 is equal to A3 plus 10. The fifth term is equal to the fourth term plus 10 more. So the next general term is equal to 1 less than this. So I can just say an minus 1 plus 10. That's how I show 1 less than this one. So that's the recursive formula. What I really would prefer you to do is to be able to do this. So what would be the term before the first term? Okay, that's C. If I think of like the term before, so 10 less than 3 would be negative 7. So if you see this formula, that's what this means is A1 minus D. So C is really negative 7. So the difference is 10, and then C is negative 7. Or if you use this formula, A1 is 3, the difference is 10, and minus 1. I distribute the 10, 3 plus 10, and minus 10. Now I can combine those like terms. So 3 minus 10 is negative 7, so I have 10 and minus 7. This is what I'd prefer over the recursive formula, but this is the recursive formula. And these are the first 5 terms. The next question, 17, same thing. My first term is 4, but now it says find the next 5 terms. So 4, and the difference means we're going down by negative 2 each time. So down 2 from that, down 2, and down 2 more. So recursively, A2 is equal to A1 is 2 less than A1. A3 is 2 less than the second term. A4 is 2 less than the third term. So the general recursive formula is whatever this number is, it's 1 less over here minus 2. And we know that we have to start with n being equal to 2, greater than or equal to 2. We have to have a starting point. Okay, so that's the recursive formula. Again, if I were to go this way, the 0th term would be 6, or you could say C equals A1 minus D. So 4 minus a minus turns into a plus, which makes 6. So now I just plug that in. D is negative 2 and plus 6. Okay. Whereas in this one, you just plug stuff in and then work it out that way. D is negative 2 and minus 1. I distribute negative 2n plus 2. There's still a 4 at the front. 4 plus 2 is 6. So an equals negative 2n plus 6. So you get the same way regardless of which formula you use. This is a little bit different way of saying that we're subtracting 2 each time. This is the same thing saying we're subtracting 2 each time. So that was number 17. Number 19. You're supposed to first of all find the formula. And you use it the same way we've been doing those other ones. So C equals A1 minus D. So A1 is 7 minus 10 would be negative 3. So now I know that my formula is 10n minus 3. Or if I do it this way, A1 is 7, my difference is 10, n minus 1, distribute that 10, 10n minus 10, 7 and negative 10 combine to make negative 3. So there's my formula that way. So now that I want to find the 22nd term, all that I'm going to do is replace this n with 22 because it's been replaced with 22 here. So it's just 10 times 22 minus 3. So 10 times 22 is 220, minus 3 is 217. So that's how you do that. So this next one, same thing. C equals A1 minus D. So A1 is 102 minus 4 is 98. So my formula is AN equals 4N plus 98. Or I could calculate it this way, 102 plus 4N minus 1. Distribute the 4, that makes 4N minus 4. 102 minus 4 is 98 plus 4N. So I get AN equals 4N plus 98. So now to find the 43rd term, I'm just going to replace the N in either equation because they're the same with 43 because that's what we're after is the 43. We've replaced N with 43. So it's 4 times 43 plus 98. So 4 times 43 is 172. So 172 plus 98 270. So A43 equals 270. Okay, question number 25. Says if somebody gets 8, or they have 8 unread emails and they're going to go on vacation. Each day they get 22 new emails. That's like the D. This is like the day that they first start. Come up with the equation for this. Let's see, I better read it carefully. Jim has 8 unread emails in his inbox before going on vacation. So this isn't day 1. This is like the day before he leaves. Okay, so that's like our C right here. So AN equals 22 new ones per day plus the 8 that he began with. Okay, so make sure you read that carefully. I had to go back and read it. So this was the day before he left. So that's our formula. It says, oh, that's all we have to do. So on day 1, after day 1, he'd have 22 new ones plus the 8 would make 30. Day 2, he'd have just 22 more added onto that. So you can see how that works. 44 plus 8 is 52. So see, we're just adding 22 each time. But if I wanted to find just the 7th day without having to add 22, I could just do that. 154 plus 8. So you could calculate it any way. You don't have to do as much. You don't have to go 22 added onto that. 22, you can just calculate whatever day you're after. So 31 says, find the 8th term of an arithmetic sequence with A1 equals -2 and A15 equals 68. So realize that I've started at A1, I've gone up to A15. I have moved up 14 terms. Okay, how far have I moved in 14 terms? Well, I started at -2 and I ended at 68. So I actually went up 70 because I was down below 2. So I've actually gone up 70 in 14 days. So how much did I go per day? So I go 5 per day. So that's our difference, is each day or hour or whatever it is, it's 5, a difference of 5. I know A1 equals -2, so I could just plug that into either of these formulas. Okay, difference is 5, N plus C. C always equals A1 minus D, so my first term is -2. Minus 5 would be -7, so plus and -7. Or if I come over here, -2 plus 5 and minus 1, distribute the 5, makes 5n minus 5. The -2 and -5 make -7. So either way, I get the same equation. So now to find A8, I can just go 5 times 8 minus 7. So 40 minus 7 is 33. I guess once you found the difference, you could have also said A1 equals -2, A2 equals 3, A4, add 5 more onto that makes 8. Add 5 more to 8 makes 13. Add 5 more to that makes 18. Add 5 more to that makes 23. Add 5 more to that. One, two, oh, I skipped 3. 3, 4, 5, 6, 7, 8. So anyways, you can do it either way. Whatever way makes you happy, that's how you do that problem. Just hit my sleepy time of the day. So we're now supposed to add all these together. So you can go to your calculator and you can add all of these in and just go 4 plus 7 plus 10 plus 13 plus 16. Or there's a trick, if you watch the notes, 4 plus 37 makes 41. 7 plus 34 makes 41. 31 plus 10 makes 41. And I could keep doing that for as many terms as there are. Okay, so that's the trick. So in question number 49, counting in my book, I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 terms. So the formula says if I take the number of terms and divide it by 2, because each of these are pairs, so 12 divided by 2, I get 6 pairs. And I go the first term plus the last term, because they're all of these make 41. So once I figure out what the first and the last added together, it works that way all the way down. So 4 plus 37, that will be my answer. Okay. So like I said, if you want to add them all together, go for it. Whatever you want to do. And this one says add up the first 40 numbers of a sequence given like this. Well, I don't know what the 40th one is, but I bet I could come up with it. I know this formula. I know my first term is 1. I know that I'm adding 5 each time. So 1 minus 5 would be negative 4. So 5n minus 4, or if I plugged them in over here, a1 is 1. The difference is 5, n minus 1. 5n minus 5. 1 and negative 5 make negative 4. Add that to the 5n. So I get the same thing each time. So the 40th number, so I'm going to plug 40 in for that. So 5 times 4 is 20. Add a 0 is 200. Minus 4 is 196. So that's my last term. So now I can use this formula that says if I know the number of terms, I know the first term, and I know the last term. So I know there's 40 terms. So 40 divided by 2 is 20. The first term is 1, and the last term is 196. We just calculated it, the 40th term. So it says add the first 40 together. So 20 times 197. So 20 times 197. 3,940. So once we have that figured out, what the first and last term are, it makes our problem a lot easier to do. So in 55, I'm going to show you the long way, and then I'll show you the shortcut way. So we know this is arithmetic because we're just going to add 6 to, so we're going to go 1 plus 6, 2 plus, so we're just changing the j each time. We're adding 6 to it, okay? So I can use this formula. So there's an 18 because I start at 1, so 18 minus 1 is 17, but that's how many there are to get from 1 to 18. I have to go up 17 more. So then I have to include the 1 which makes the 18 terms. So that makes 9. So what I have is 9 times the first term. So the first term is when I plug 1 in. And the last term is when I plug 18 in. So 18 plus 6 is 24. So 9 times 7 plus 24 is 279. Okay, so here's the shortcut way. You go to your calculator. You hit math. Go up and see this one that says 0. So you can just hit 0 from now on. There it is. So instead of j, I'm going to use x. And I'm going to put a 1 in there. And we went all the way up to 18. And then in our formula, it said j plus 1, or j plus 6, sorry. So I'm going to go x plus 6. So I just replaced that variable with x instead of j. And I hit enter. And there it is, 279. Okay. So on this next one, I can do the same thing. 1 to 15 is 15 terms. The first term is 1 minus 3, which is negative 2. The last term is 15 minus 3, which is 12. So 12 minus 2 is 10 times 15 over 2. So that's 150. Cut it in half is 75. Okay, again, I can go to my calculator. I can hit math, go to 0. There it is. I type in x. This one started at 1. It went up to 15. And then it was x minus 3. And there's our 75 again. Okay. I guess if you really wanted to, you could calculate out all the terms. You could say the first one is negative 2, the second one, 2 minus 3 is negative 1, the third one is 0, the fourth one is 1, and so forth, and then just add them all together. If that would make you happy, you're welcome to do it that way. So whatever you want to do. 57, that's a 50 up here at the top. So x equals 1 to 50. So math, 0, x equals 1 to 50. And then we had 2x plus 6. And I hit enter. 540. So if you don't like it this way, the first term, I plug 1 in there. 2 times 1 is 2, plus 6 is 8. So A1 equals 8. A50, I plug 50 in there. 2 times 50 is 100, plus 6 is 106. 1 to 50, 50 minus 1 is 49, but then I have to include the first term. So that makes 50 terms. The first term is 8, 106. So 25 times 114. So 25 times 114. Whoa. I messed up somewhere. Oh, I typed in 20 on that one. So math, 0, x, 1, 50, 2x plus 6. There we go. Now we get the same answer. So anyways, as long as you don't mess up, it does it right. It just does what you tell it to do, though. Shouldn't have erased the answer, though. So that's not right. Second, enter. There we go. So 2,850. So now on this one, I don't know how many terms there are. I know I'm adding 5 each time, so my difference is 5. So I know my last number is 49. I'm going to work backwards. AN equals DN plus C. So my last number is 49. My difference is 5. I don't know which term it is. And I know the term before this one, C equals A1 minus D. So negative 1 minus 5 was a negative 6. So then I can add 6 to this. 55 equals 5n. Divide it by 5. So n equals 11. So I've got 11 terms. So 11 over 2. My first term is -1. My last term is 49. So that makes 48 times 11 halves. So 11 divided by 2 times it by 48. And we get 264. And that is the end of that section. So anyways, that's how you do those problems in different ways.